These notes are on piecewise functions. For piecewise functions, just a reminder, domain are the input values. In a piecewise function, we use domain to indicate where a piece begins and ends. Range are the output values of a function. So a piecewise function is a function which is defined by multiple subfunctions, where each subfunction applies to a certain interval on the main function's domain. So let's look at a couple examples. Example 1, given the following graph, write the piecewise function. So I can actually see three functions here. I can see one that goes from here to here, one that goes from here to here, and one that goes from here to here. And by the heres, we mean the x's. So I have one function that hits these, has those x's as its domain, one that has these x's as its domain, and the third has these x's. So this function has three subfunctions in it. So we'll call this function f of x. I'm going to use some brackets, and I have three subfunctions. I'm going to write the domains first. So my first domain here is from -2, and it's a closed circle, so less than or equal to x and to 0. And I'm going to use the open circle here. Alternatively, I could write this as -2, 0 with bracket around the -2 and a parentheses around the 0. And we'll talk about that parentheses in just a moment. My second piece goes from 0 to +2. Now, my function is continuous, meaning there's no gaps. When I draw it, even though I'm doing different shapes, I don't have to pick up my pencil, which means that either the first or the second subfunction have to include 0. I chose, in this case, to have 0 be in the first in the second, so that's my or equal to function. And then I'm going to follow that pattern and have the 2 be in the third subfunction. And again, I could also write that as 0, 2, depending upon if you like set notation or interval notation. My third function begins at 2 and ends at 4. And because that 4 is a closed circle, that's an or equal to. So 2, 4 with brackets around both. Now comes the part where I have to write the actual functions. And I'm realizing that I probably need more room to write the function, so I apologize for the lack of space that I just created for you. Let's have this go all the way over here just to be nice and safe. So my first function goes through the point -2, 4, -1, 1, 0, 0. And so I recognize that as the x squared function, x squared. My second function is linear. It goes through the point 0, 0, and it goes through the point 2, 1. And so I'm going to use point slope form here because it's actually more straightforward than any other method. So in this case, I have my slope is up 1 over 2. My point is 0, 0. So you could also write that as 1/2 x. In this case, because the point I'm using is 0, 0, it's the benefit of using point slope form here is less clear, but it will be a lot clearer here. So in my third subfunction, I can see I have a slope of 3, and I'm going to use this beginning point right here. So that point is 2, 1, so x minus 2 plus 1. And I don't have to simplify that. I don't have to distribute 3 and combine like terms. I can simply leave that in point slope form, which is why I wrote the middle equation, the middle subfunction in point slope form also, even though that one can be simplified to 1/2 x. Let's look at another example. In this case, we're given the function and we're asked to graph it. Now, there are several ways to do this, and I'm going to show you two different methods. Some students will like the first method better, the second. Use whichever method you feel most comfortable with, and that, make sure that your teacher is comfortable with, whatever method you're using. So the first method, what I'm going to do is I'm going to graph each of these functions as if what they are. I'm going to graph them exactly as the functions are. So I have a parabola here where the vertex is at 1, -3. So 1, -3. And my A is 1, so my pattern is over 1, up 1, over 1, up 1, 2, 3, over 1, up 1, 2, 3, 4, 5. And then I mirror image those. And then I connect the points. So I am ignoring currently the domain, the subdomains. My second function is a linear function, and it's written in point slope. So I find my point. My point is 2, 3, and my slope is -1/5. So up 1, back 5, up 1, back 5, 1, 2, 3, 4, 5, or down 1, forward 5, 1, 2, 3, 4, 5, and I connect those. Now I have to clean this up, though, because I do have subfunctions here. This isn't two separate g of h and h of x functions. It's actually just one huge function. So the first thing I'm going to do is I'm going to look at my first function. And it says that my first function begins at -2 and goes until +2. So -2 would be right here, and it's an open circle. So I put an open circle there. And it goes to +2, where it is also an open circle. And then I'm going to take a highlighter and just highlight that portion. If you're using a pencil, the best thing to do is to erase. But I am using pen here, so ideally you would be using pencil and erase. That is the best option here. The second function begins at 2, but it's a closed circle. There's that closed circle. And it goes to where x is 12. So unfortunately, my graph needs to go a little bit further. So 11, 12, I apologize for that, but it's an open circle there. And so then I highlight that portion. Again, using a pencil here will make this a lot prettier. So I'm going to actually use a whiteout at this point, just so that you can be very clear on this portion would go away. This portion would go away. This portion is not highlighted. This portion that is not highlighted. This portion that is not highlighted. Again, so much easier with a pencil, and this portion that is not highlighted. But now I can see that piecewise function. It's got the two pieces, it's got the parabola piece, and it's got the linear piece, and that's what it should look like in the end, with open circles on the two ends of the parabola piece, closed on the left-hand boundary of the linear piece, and an open circle on the right-hand side. So now comes a second method. For my second method, I am going to use pencil in this case because it'll be a little easier. I'm going to break the plane up into the boundaries that it's got here. So I have -2. So -2, so I'm going to draw a line right here at x equals -2. X equals +2. Again, I really apologize that I didn't extend my graph out as much as I should, and +12. So I have 4 regions. I have a region out here that is blank, so nothing goes here. And I have a region out here on the right-hand side that's blank. Nothing goes there. In this middle portion, I have this parabola. So let's graph it. -1, +3. Oh, whoops, sorry. Totally backwards that. +1, -3. Then I have a slope of over 1, up 1. And then mirror image that, so then over 1, up 3, and over 1, up 5. I have an open circle. I have an open circle, and then I can connect. In this portion, I have a linear function where my point is 2, comma 3, and it's a closed circle, and then a slope of -1/5. So down 1 over 1, 2, 3, 4, 5, down 1 over 1, 2, 3, 4, 5, and that's an open circle. And then to clean this up, I can erase the parts that don't matter. And when you're doing this, of course, you can use lighter pencil. You don't have to draw it as darkly as I drew it. That was mainly so that you could see what I was doing. You can also, go over it again with highlighter to be like, this is my final answer. Just, again, check out with your teacher if they have a preferred way for you to showing your final answer. The last thing that we're going to do with piecewise functions is we're going to find particular values for our piecewise functions. So the point here with piecewise functions is that I have different domains. So when I'm asked to evaluate a piecewise function, I need to make sure that I'm plugging my x value in to the right sub-function. So if I'm finding g of 1, evaluating g of 1, I need to ask myself, what does 1 sit in the first sub-function's domain or in the second? It sits in the first. 1 is between -2 and +2. So I say that that is x. Oops. I'm using my first function and I'm plugging in 1 for the x. So 1 minus 1 quantity squared minus 3. Which equals 0 squared minus 3, which equals -3. G of 2. Now G of 2 is going to be the trickier one because the 2 actually sits in both of these sub-function domains. However, if we look very carefully here, we can see that 2 does not actually sit in the first sub-function's domain. The first function goes all the way right up to 2, but not at 2. So 2 actually sits in the second subfunction. So I have -1/5, 2 minus 2 plus 3, which is -1/5 times 0, which is +3, which is 3. And my last example is G of 7. So again, I'm looking and seeing which subdomain does 7 sit in. It sits in the second one. So I have -1/5 times 7 minus 2 plus 3, which is -1/5 times 5 plus 3, which is -1 plus 3, which is +2.